Good evening, and thank you for joining us tonight. The mission of the New Jersey Astronomical Association is to promote and encourage interest in the science of astronomy. Please visit our website for more information and do consider joining our organization. We are privileged this evening to have Dr. James Rice presenting. Dr. Rice is a co-investigator and global and geology team leader on the Mars Exploration Rover project, which includes Spirit and Opportunity, and also has mission experience working on the Mars Odyssey Orbiter and Lunar Reconnaissance Orbiter projects. There is a link in the comments where you can learn more about Dr. Rice. This evening, Dr. Rice will be speaking about the 2020 Columbia Hills Regional Landing Site for the Mars 2020 rover. Please post any questions that you have in the comments where we will review them at the end of his presentation. And we will say over to you, Dr. Rice.
Okay, first of all, good evening, and glad to be here talking to y'all tonight. I guess the first time I did this was almost exactly 5 years ago. I believe it was June 27th, 2015, when I presented. Hard to believe 5 years have gone by, but I'm glad y'all had me back. And I'm going to talk to you tonight, as Jim mentioned. First of all, I want to thank the New Jersey Astronomical Association for getting me back here. And I know we're under some strange times we've been living in the last several months, but and up in your neck of the woods, y'all have had it a little tougher than out here in Arizona. So I hope y'all guys are getting better there and starting to have some semblance of getting back to sort of normal. But I'm going to talk to you tonight about the Perseverance rover, which used to be called the Mars 2020 rover. It was just named a couple months ago by a student. I can't remember what grade he was in, but he was a grade school student in Virginia. Perseverance is kind of the way we've been naming our rovers for a while now, having a contest for school kids. I'm going to talk about that mission and update. It's going to launch this summer. And also I'm going to talk to you about something personally I'm more excited about, believe it or not, even though I'm a Mars rover person, is the Artemis project, which is the plans to get American astronauts back on the moon by 2024. So I'm going to start out with the Perseverance rover and then at the end go into the Artemis program. I don't know if you know much about that. So hopefully I'm going to give you some information if you're not well aware of that program, which is going to be very exciting in the years to come. So my next slide is a little bit about me. I've been interested in space since I was 6 years old. This is a picture I drew. My mother kept, and I know the date on it is 6 years. I was 6 years old, so I know I've been interested in space at least that far back, if not maybe a little further, but this is for certain. And you can probably see why I didn't become an artist, because I really have not hardly any artistic skills. But I had a rocket there, and I guess that was Saturn up there in the upper part of the picture there. But for any kids in the audience, especially, I don't know how many are out there, but this, if you look at this report card, you're thinking this person's report card is pretty horrible, and they're probably going to end up going nowhere in life. Do well. This is my report card when I was in 7th grade. I was never the best student. There are some subjects I was in better than others. I have 2 brothers and 2 sisters that were younger than me, and they always made better grades than me. In high school, they were in the National Honor Society and all those things. And I put this up here because if you make straight A's, that's great. Keep doing it. More power to you. But that wasn't me. I was never a straight A student. As I got into college, my grades improved because I started taking subjects I really cared about and was more interested in. But if you're not doing that good in school, all hope is not lost, believe me, because you can look at this report card and I was kind of amazed how bad it was. I knew I wasn't that good of a student, but this kind of shocked me when I saw it. My mother had it back in my hometown, Tuscaloosa. I went back to visit her, and I was kind of surprised how bad that was. But there's still hope for you. And I think everybody is put here for a reason, and everybody's given certain gifts or skills or talents. And one of the hard things in life is to figure out what that purpose is and to go and apply yourself. And for me, like I said, I was pretty lucky. I was interested in space really from my whole life. And so it gave me some direction, something to shoot for. It wasn't an easy path, and it was very circuitous. But if you never give up, stick with it, and had a lot of help along the journey, you can do the impossible things. And for me, when I was growing up, the world doesn't really change a whole lot. The locations of things change, certain circumstances, but when I was growing up, the war the United States was involved in was the Vietnam War. I had some cousins that went over there. Now, we've been in the Middle East for some number of years, so these wars come and go. There were riots on the streets when I was growing up, and university campuses, and political assassinations. A lot of bad things were going on. But the thing that caught me, I remember this cover of Newsweek magazine, the picture in the center. That was in October of 1968. I was 9 years old, and I remember that picture of the astronaut training to practice to go to the moon. And the thing up there to notice is racing the Russians, because at this point in October of 1968, it wasn't a foregone conclusion the United States was going to be the first country to put people on the moon. Most people thought the Soviet Union was going to do this. They had a big lead over us. So I grew up in the Apollo program, and looking at the moon before people ever went there, and thinking that the Russians might get there before us. And to put this in context, October 1968. You remember Apollo 8 got there on Christmas Eve of 1968, a couple months later, in the famous reading from the book of Genesis. And the Russians were racing us up to the very end. A lot of this came out after the Cold War ended, and a lot of files in the Soviet Union became accessible. They were all gung-ho trying to beat us to the moon. They even had a lunar lander they were working on. Their program was only going to land one astronaut on the moon as opposed to Apollo landing 2. But they were trying to do this up until the last moment. So there was definitely a race to the moon. And this right here is something that I'll never forget. I was 10 years old when Neil Armstrong first set foot on the moon on July 20th, 1969. And this just solidified my future, what I wanted to do with my life, to see the almost impossible happen before your very eyes. And like I mentioned, the Artemis program, for the young people out there that didn't see Apollo, don't lose hope, because in hopefully about 4 years, you'll see Americans back up on the moon again. And the TV quality will probably be a whole lot better this time. We'll have HD TV. And you'll see a lot of amazing things. And hopefully some of you out there will be inspired to pursue careers in this field, because the country is going to need a lot of future scientists and engineers in the years to come. This is kind of just a snapshot of my life. Once again, I had a book report I did about the suit they were going to wear when they got to the moon. I built the Estes model rockets. That's a picture of my room down there. My heroes growing up were the Apollo astronauts, and I wrote letters to them. They would send me autographs back. I still have them to this day. And NASA would send you big packets of information to read, and I would just wait for the postman to come almost every day when I write these letters. But and if you look at the picture down the lower right, several decades later, my dreams came true. In the background, that's not a model rocket. That's a real rocket taking one of our rovers, the Spirit rover, to Mars. That's a Delta II rocket. It's about 125 feet tall. And I was down there. I got selected by NASA to be on the science team for Spirit and Opportunity. I was a geology team leader. And I was down for both of the launches. And it was really an amazing thing, and to be part of a team like that. And the last time I spoke to you 5 years ago, I was talking about the Spirit and Opportunity rovers. I read this book growing up, The Martian Chronicles by Ray Bradbury. I got to meet him several times before he died out in California. And I put this in here because it's one of the most famous books about science fiction books about Mars. But it's also going to be his 100th centennial, 100th year of his birth, this August 22nd. Since he was born. He died back in 2012 in June. But he was an amazing person, a very nice guy. I met him at his house several times, and really it was an honor to kind of meet this guy. Somebody I thought I'd never meet growing up. I put this in here. This is a movie that came out in 1965 that probably most people never even heard of or never saw. And it's not the best movie in terms of special effects. It's called Robinson Crusoe on Mars. If you watch this movie, you're going to think this sounds very familiar. That's basically The Martian, this movie made in 1965. Now, The Martian made a lot more money, had better special effects and such. But if you ever get a chance to go watch this movie, you'll see a lot of similarities with this movie, with The Martian. Now, we're getting ready to launch a rover to Mars this summer. And it's not a done deal. It's going to get there in one piece and successfully land and start doing its science operations. Mars is called the graveyard of the solar system. The planet Earth has sent numerous missions out there, orbiters, landers, rovers, flybys since the 1960s. And you can see the success rate is very bad. 2/3 of all the missions out there have been failures. The United States, we've been pretty fortunate. We've had some failures, but we've had the most success at Mars. To this day, we're the only country that has landed successfully on the surface of Mars. So it's not a slam dunk that Perseverance is going to get there in one piece and work. We think it will. We're doing all we can. We have a good track record of experience to draw upon. But Mars is a tough place. And, it's you never count your chickens before you hatch when you work on a Mars mission. And I worked on one back in 1999 that crashed near the South Pole of Mars called Mars Polar Lander. And I spent 2 years of my life getting ready for that. And then basically in the blink of an eye, the mission's gone because it crashed. And when you're a scientist on a science team, you lose your job. Engineers tend to move on to the next project, but the scientists are kind of left twisting in the wind. So it was a tough time to go through. And this picture of a cemetery is a fitting picture because when you go through one of these, it's like being at a funeral and people are crying, they're losing their jobs. It was not a pleasant thing to be around. I don't want to say I'm glad I went through it, but it makes you really appreciate when the things work, when you work on missions that are successful. And this was in 1999. I got lucky and got selected by NASA for the twin rovers Spirit and Opportunity. We landed in January of 2004, and obviously they both worked, and it was a great success. But I think I appreciated it a lot more than some other people on the team that never went through one of these failures. So it's we think that Perseverance is going to work, and but we got to just hope for the best on this thing. We've done all we can on planet Earth, and we're going to launch that thing this summer, and then it's kind of on its own. And since I talked to you last, the Opportunity rover no longer is. It ceased to work or died where we used for it, even though it was a machine. It died in February of 2019. When we were trying to continue to send commands to it, a dust storm took it out, and basically we think it froze to death. There's this giant dust storm that hit Mars back in the summer of 2018, and we continued throughout the summer and the fall, and even the early part of 2019 to establish communications, and we never were able to do that. So we lost it, but we got 15 years of operations out of it. We were only supposed to last 90 days. So it was tough because our team doesn't exist anymore. We had one of the greatest teams of scientists and engineers ever to work a planetary mission, because all the old timers at the Jet Propulsion Laboratory would come by and said they've never seen a team like we had. So we had a great team of people, and it was kind of sad to lose that, and also it's sad to not turn my computer on and look at new pictures of Mars every day. We would get down, and that was one of my jobs to study that. And I still miss doing that every morning, because that was something if you do for 15 years, it's a hard habit to break. But Opportunity really can't be too upset. We got more than we ever dreamed we would get. And there never would have been a good time for the mission to end, because there's always going over the next hill or do the next crater field. And so, but I guarantee you got your money's worth as a taxpayer for these missions. These were some of the results we got back. I don't want to go into a lot of these, but we found lake beds on Mars, the first time that was ever found. Up until this point, it was a theory, and a lot of people ridiculed that theory that there were ever lakes on Mars. I went through that period of my time when I was in grad school. That was what I worked on for my dissertation. People thought you were crazy if you believed there were lakes on Mars. And it was really neat for me to be on the team that found the lake beds on Mars and to prove a lot of those people that were naysayers wrong. We found evidence of a relatively warmer climate. Now, when we say warmer climate, it was never like Florida, okay? Probably the best the best Mars got was like Antarctica. It's always been a cold place. Found abundant evidence of a watery past. We found evidence for an ancient volcano, a lot of past flowing waters, and these conditions would have been right for life. We were a geology mission, so we didn't have biology instruments, so we weren't able to identify any fossils or anything like that. But we found the environments where if there was life on Mars, it would have thrived early in its history, which was a lot like Earth early in its history. I mentioned when I'm talking here tonight about the 2020 rover. This was the countdown clock is underway. This was taken about 35 minutes ago, actually 45. So in about 54 days, the launch window opens. That is a selected period of time that you have to fly to Mars. If you don't make it between July 17th and August 11th, you have to wait 26 months for the planets to realign to go. So that's one, the first critical milestone we have coming up in this mission is getting it off the pad down in Florida on its way to Mars. And so everything's looking good, even with the virus. It's still on schedule, and I think we'll meet it. And like I said, the launch window opens on July 17th, which is the earliest it will launch, and we're going to try to aim for that date. But as you know, if you ever been to Florida in that time of the year, weather can be really iffy with thunderstorms. But we're lucky with the timing on this one because we're going to launch in the morning versus the afternoon. So that helps get away a lot of those afternoon thunder showers in the Cape area down there. So the countdown is ticking. If you go to the Mars 2020 rover website, you can see this countdown as it clicks away. This is the 2020 rover, now called Perseverance. If you're familiar with the Curiosity rover, at first blush, it looks pretty much like the same type of rover, and you're right. There are a lot of similarities. There are some subtle differences, though. The 2020 rover's main goal is to collect rock and soil samples that will one day be brought back to Earth in some future missions that, as we speak today, are not funded. So I can't really give you a definite timeline. We have a timeline out there, but these things are all dependent on funding, so they could change. But you can see it's got this big arm sticking up there. It's going to take little rock and core samples, and in the future, we're going to bring them back to Earth and study them, because the way we look at it, the best laboratories are on Earth, the best scientists are on Earth. So if you can get those samples back here, we can do all this detailed work. You just can't miniaturize and fly on a spacecraft. And one of the key things we'll be looking for in these samples is evidence of any life, but also we're going to learn about past geologic history of Mars in this area and the climate. So there's a lot we'll learn, but life is the one that always kind of gets the spotlight, which is something definitely we're going to look for, but there's a lot of other good science that goes on with this. This is kind of just a mission timeline. I mentioned the launch window starts this July. We cruise to Mars, and I can tell you we're going to land on Mars on February 18th, or we're going to crash. Based on orbital mechanics and Sir Isaac Newton, we know exactly when this rover is going to land and where. It's going to land in a place called Crusoe Crater in the northern hemisphere, about 19 degrees north latitude. It's an ancient lake bed with a delta in it. And once again, it's going to land on Tuesday, February 18th, or either we're going to make a new crater on Mars on that day. That no matter when we launch in that window, between the 17th of July and 11th of August, we're still landing on February 18th. And the reason, you may not know this, that window just got extended 6 extra days a couple days ago, because now the spacecraft, believe it or not, you have to, when we get it down there before we fly it, we have to perfectly balance it and weigh it. And once you get these numbers in there, with the spacecraft ready to go, it helps the trajectory people with their analysis. And so we're able to squeeze out some extra days in that window, which is always a good thing to have. So the landing site I mentioned over there is Perseverance, and you can see that in relation to all the other landing sites that we have successfully done. And these are all American landing sites because no one else has landed there. I could have put a map with the crash Russian and European sites, but I felt, don't want to clutter it up. But anyway, you can see where we're going with Perseverance. It's going to land very similar to Curiosity. If you remember that back in August of 2012, it's going to come down with a heat shield at first, then a parachute. Then this sky crane, like a Buck Rogers jetpack, will operate. And this works towards the final sequence of descent. And the rover gets lowered down on a cable, and the wheels get deployed. They're folded right here in this picture. And the rover, once sensors detect it, 6 wheels are on the ground, that cable gets cut, the sky crane flies off and crashes about 1 kilometer away, and the rover is pretty much kind of ready to go. And so this is where Curiosity landed. It's an amazing technology, the engineers that did this. It's unbelievable. Pinpoint landing. And so Perseverance is going to do this on February 18th. These are some of the science instruments that are located on the 2020 rover. And I'm not going to go through all these, but it's primarily going to be to help us collect the proper rock samples and soil samples to bring back. So we want to get the ones that are, what we call it inside the most juicy samples. So we don't want to just get ho-hum stuff. We want to get the things that are most critical for answering questions about life on Mars, the past climate, the water history. And I guess that kind of wrong. I guess we do want some ho-hum because we do want a couple samples of the average because we use that as a calibration point to see what the planet is like. So, but the primary goal to fill these canisters up is going to be, samples involved with water with the search for life. This is the 2020 rover compared to some differences from the the Curiosity rover. And like I said, you don't notice a lot of these things. The wheels are a little different because if you follow the Curiosity rover, they were basically like Coke cans getting punched full of holes in the pointed rocks. The engineers went back and redesigned the wheels to make them more sturdy. Actually, these wheels are more like what we had on Spirit and Opportunity. And I still to this day don't understand why they changed that design because we had a proven design and we went all over all kinds of rocks and terrain for 15 years. But anyway, you live and learn. The engineers learned their lesson, I think, the hard way. This rover has a few more cameras on it. It's got its cross beam across there. If you see the aft cross beam, Curiosity didn't have that. That is added just to give it a little more structural integrity. The big thing is this arm, this big thing out there with the turret. That's the percussion rotary hammer. They're going to take the rock cores and the core samples out of there from sediments and rocks and soil samples, and they got a sample caching system where they're going to be stored and put in the canisters. And Curiosity didn't have any of these things on there because it wasn't this type of mission. So, but overall, it looks pretty much the same. This is, I was able to go out to JPL on December 27th, get in the white room. First, you had to suit up in all this, the bunny suits. I guess the clothes we had on would have been pretty good for the virus. It came a couple months later, but you had to go through there. They were very strict about being clean because you don't want to contaminate this. This is the actual rover, Perseverance, sitting right here. And I was able to I couldn't get any closer than about, probably about 6 feet away from it. There's a technician in there just to give you a scale. It's about the size of a Mini Cooper car. It weighs 2,000 pounds. And this is in the clean room at JPL before they buttoned it up and mailed it down to Kennedy Space Center. That's a picture of me, and that's the rover in the background. It was just kind of neat to get in there that close to it. And like I said, you had to put all this gear on. It took a while to get geared up and put this stuff on. Somebody to come by and check you, make sure everything was good to go. It was an ordeal. It was a lot easier getting out of it than getting into it. They put a lot of tape around your duct tape. It's like a white duct tape around the gloves. They didn't want anything with any possible contamination getting on this rover because you don't want to test a false positive on Mars. Think you found evidence of life, and it was something that you picked up on Earth. So the cleanliness was very strict, like all Mars missions are. And this is when it gets unloaded down at Florida in February in the canister. So it's down there now. And this is going to be a neat mission because it's got a rover, but it's got a helicopter. The first time an aircraft will fly on another planet. And this helicopter weighs about 4 pounds. It's a technology demonstration mission. So it's not guaranteed it's going to work, but we think it will. But that's why you do these things. It's got dual rotors. Those rotors are about 4 feet in diameter. And this thing is bolted down the bottom of the rover. This is a picture down again at Kennedy Space Center. This was taken probably about maybe a month ago. The rover is on the bottom chassis of the rover. Excuse me, the helicopter is on the bottom chassis of the rover in this picture. And it's going to have a protective cover put on it. It hasn't been placed on there yet to shield it from any dust or rocks being kicked up during the landing sequence. Gives you an idea of the scale of the helicopter, some technicians next to it down there in the clean room. And I don't know if any of you sent your name to Mars. There was you had the possibility to do that up until last September, I believe. And if you did it, those 3 little squares up there are where all your names are etched in there if electron beams. So there's about almost 11 million names are going to Mars. And that's where it's bolted up there on that aft chassis stiffener back there in the back part of the rover. So that's where your names are if you did that. This is the landing site. This is Jezero Crater. It's about 40 miles across, and the dark ellipse is we're going to land somewhere in there. And depending on the winds that day, it will dictate. But I bet you we land pretty much dead center. We're pretty good at doing these things now. And you can see the delta up there coming from the left part of that crater through a channel. So this was a lake, probably 3.5 billion years ago or so. And you're familiar with deltas, probably the famous one, the Mississippi River Delta. But there are deltas. Anytime a channel empties into a lake, you get a delta forming. So we've got one of these on Mars. We're going to explore with Perseverance. This is Perseverance artist rendition. This would be reality here in less than a year with the landing. But you can see out there in the foreground all these little sample canisters. We're going to leave them on the ground for a fetch rover to come some years later to pick up and bring home. But that's kind of showing what we're going to do. This is the size of these little cores in the rock, the sample containers. That rock core is about, I think it's a 1/2 inch in diameter. And so it gives you an idea of the scale. We're going to be able to collect 31 samples of rock and soil. And then if the funding shows up and everything, it's always about money. In 2026, we'll launch the sample return rover called a fetch rover now, and a lander. And this is a artist rendition of it landing. So it'll probably land in 2027 about. This is the fetch rover. It's very simple, solar powered. It will go, and you can see some of the sample canisters sitting out there on the Martian surface. We'll know exactly where they are to come pick them up. It will have an arm to pick these things up and load them on board. It will bring it back to a lander, and then we'll launch it from that lander with a solid rocket up into Mars orbit, the samples. And up there, there's an orbiter going to be waiting to pick up the sample canister and bring them back to Earth. That will be launched in 2026 also. These are separate launches. And then if this timeline stays on course with the funding and everything, the samples will get back on Earth in 2031, so a little more than 10 years ago. They'll land out in the Dugway Proving Grounds in Utah and then be brought to laboratories, probably in Houston, Texas, to be studied by the scientists. And it's going to answer a lot of questions about Mars. Obviously, the life question is a big one. But, we don't know exactly how old some of these things are on Mars, these surface features like volcanoes or channels or canyons. And once we can date these some volcanic rock, like we do, with uranium, strontium, rubidium dating here on Earth, we can get exact timelines. And we can say this lake formed, 3.1 billion years ago, because we have samples from there. We can radiometrically date them like we do samples on Earth and the samples the Apollo astronauts brought back. And by doing that, you can also calibrate our crater curves, because what we do now, we count craters, believe it or not, in a unit surface area. And basically, the more craters are there, the older the surface. It's a relative time frame. So we can say one surface is older or younger than another, but we don't know about how much. We don't have any real absolute dates. Once these samples get back, we can start doing that. And a lot of people aren't aware of that. That's going to be a game changer for the geologic history of Mars. And that's what we're going to get by bringing those samples back. And like I said, obviously, we're going to look for signs of life also. But there's a lot of other good science going to happen that kind of gets overshadowed by the life quest. This is sort of our evolution of kind of turning into a Martian. You can see the first rover way over there on the far left with a Sojourner rover from Mars Pathfinder back in 1997. Then you have Spirit and Opportunity. Then you have Curiosity, and then Perseverance. And then somewhere down the line, astronauts. That's what everybody wants to see. That's what I want to see, although it seems like it's always 20 years away. So the earliest we'll get astronauts on the Martian surface is probably going to be the late 2030s. Things can change on a dime, but that's the timeline, the way it looks like right now at the earliest. So it's all to be determined at this point, because once again, as I mentioned earlier, it's all about the funding. If you don't have the proper funding to build, test, and fly these things, you're not going anywhere. So eventually we'll have a base on Mars, and people will start, I think, doing increments on Mars, kind of like they do on a space station now. It'll be a lot longer increments. But, a trip to Mars and back is about a 2.5, 3 year round trip. So it's going to be a long journey. I hope I get to see this because this is going to be an amazing thing to see. The thing is, we can do it. We have the technology to do it. It's just the willpower, and part of the willpower is getting the priority to making it, the funding to make it happen. We know how to do this. We have the science and engineering, the technology to do this right now today. So hopefully this is going to happen. But before any of this is going to happen with astronauts on Mars, we've got to get back to the moon. And this goes into Project Artemis, which I mentioned earlier. This is the official logo of Project Artemis. And if you remember, Apollo was the name of the program that took us to the moon in the 1960s. Artemis, it's a neat story. Artemis is the twin sister of Apollo. And so this will be the logo. The colors are symbolic. The blue is the crescent Earth. You can see the gray moon out there, but you also see a red streak going through that. That symbolizes the moon is going to help us get to Mars. And the white stylized A is also like an arrowhead. Artemis was she was an archer, and she's the goddess of the moon. So so this is all about going back to the moon, but it's helping us prepare to go on to Mars. And this is a necessary step because the moon is only 3 days away, and there's a lot to learn on the moon. The moon is not what we thought about from Apollo. Now we know there's ice, the South Pole and North Pole, and these craters that have permanently never get sunlight. They're shadowed. There's ice down there. So that's a resource for rocket fuel, for oxygen, for water to drink. So we're going to learn to live off the land on the moon. And this is going to be technology critical for when we go to Mars, because we're going to have to live off the land up there too. So and you want to go back to the moon as a test bed because it's very close. If something goes wrong, you can get home. This is what we think these early expeditions were going to look like, and we're going to land somewhere different. We're going to land near the South Pole of the moon, and the first landing is set for 2024. Artemis 3 will be the name of that one, and this is real. This is the president and vice president Pence heads up the National Space Committee, and he was in Huntsville, Alabama on March 26th of 2019 and gave the speech that we're going to the moon and we're going to get there by 2024. And NASA is doing everything. The funding has been there so far. There's a lot of big hurdles coming up in the next year and so. But the United States is on the way back to the moon, and I think if I was a kid, I'd be very excited because you're going to see people walk on the moon in about 4 years, and I think this is going to instill a lot of interest in science and engineering for young people growing up. It's going to be inspiration, just like Apollo was for me. Apollo is why I'm talking to you today, as I mentioned earlier, and so this is a real thing, and it's all happening now. And the reason we're going back there is to the South Pole. That's where this ice is, down there in these craters that are permanently shadowed. And so we're going to this is going to be a very different landing site and technology than Apollo. We celebrated the 50th anniversary of the Apollo 11 mission last July. It's just some areas we're going to go possibly in the South Pole. Shackleton Crater is a favorite site to land on because the rim of the crater is in constant sunlight, okay? And when you go down into the crater, that's where the ice is. You don't have to go very far. There are other craters like that. You can see them in this illustration off on the left-hand side. But the reason you want this ice is the most valuable, water is the most valuable resource in space exploration, more so than gold or platinum or silver or any of that stuff. Because with water, which is going to be in the form of ice, you can obviously melt it and filter it, and you got drinking water. You have to have that. If you ever go hiking, every gallon of water you have to hike with, that weighs 8 pounds. And if you start going on long expeditions to the moon or Mars, especially Mars, you're going to need a lot of water. And if you got to lift all that water and take it up there, that means very expensive. But if that water's sitting up there already waiting for you, that cuts the price down big time. You have to go in there and get it. And so we're going to learn how to do that on the moon. And this will also be applicable to when we get to Mars. But you also have, like I said, you melt that ice, you have drinking water, you break that water apart. Water is H2O. You get oxygen to breathe. Well, also H2O, when you break it apart, hydrogen and oxygen, that's rocket fuel. So if you remember when the space shuttle used to fly, that big orange tank was full of liquid oxygen and liquid hydrogen. And that was water vapor clouds coming out at launch. But so the water is very, very valuable. And there's only a few places on the moon that have access to this resource. So the deal is, why do we want to get back there? Well, there are some people around the world that want to get there too, and some of them aren't exactly our friends. I'm talking about China right now. China is talking about going to the poles of the moon, getting this ice. And the thing about it is, there's limited locations where you want to get this area where the ice is, and you're up there in sunlight. On the rim, so you have solar power, but also your thermal regime is not as drastic as going from dark to daytime temperatures on the moon, which swing 250 degrees each way. It's a 500-degree change total. That wears out equipment and stuff. And so if you get on these rims of craters, these ridges, or sometimes they're called the peaks of eternal light because it's at the South Pole, the sun never sets, okay? But there's only certain places like that. We want to get back there to establish American leadership and a strategic presence there. I think, frankly, we want to be there when the Chinese show up before they get there. Because they're making no bones about it. They have a rover on the far side of the moon right now that landed a little more than a year ago. First ever landing on the far side. Now, there's no people on that. It's a robotic mission. But China is serious about the moon. They just tested a spacecraft out a couple weeks ago that is basically going to be able to take their astronauts to the moon. Now, it's not a lander. It's just like an Apollo or the Orion. But they're going, and I think we want to be there because it's strategic. This is the ultimate high ground. It's about strategic presence and being able to control, or at least be able to have a say-so in that distance between the Earth and the moon, which is called cislunar space. That's going to be very valuable in the decades to come. And the nations that are out there doing it are going to reap the rewards. And so if you sit back on your hands and think, oh, we don't need to do that, other countries are going to be doing it, and you're going to get left out. So I think we want to be there before they show up because they're going. This is our Orion spacecraft, which is very similar to Apollo from the 60s. This is the real thing. This has already been through the clean room. It's ready to go. It's going to fly on the Artemis 1 mission about a year from this November. It's going to have no people on the first one. It's kind of a shakedown cruise to test everything out. It's going to fly on a brand new rocket booster. Here's comparison to Orion to the Apollo command service module. Looks very similar. There are some major differences. So that's what we got. And I mentioned the Chinese have something very similar to Orion. They just tested with unmanned a couple weeks ago. So they're going to the moon. There's no doubt about it. And now they're finally admitting it. They still don't want to say a time. I don't think they're ever going to say it because they don't want us to really know what they're doing over there. But I think if the funding stays, we'll get there by 2024, and we will beat them. Now, this is the core stage, or the first stage of the space launch system, which is going to be the rocket that Orion launches on to get us to the moon. And if you look down there, you can kind of see people for scale. It's sort of a fisheye lens, so you really can't get the right perspective. That just rolled out of the plant, the NASA facility down in Louisiana. It's in Mississippi now at the Stennis Space Center. This is 212 feet long. It's got 4 big engines back there, RS-25 engines, and it's going to have 2 solid rocket boosters attached to it. But this is where it is right now at the test stand, B2 test stand at Stennis Space Center in Mississippi. It's being lowered in there, and we're going to do a big engine test, hopefully around Thanksgiving time. The engines are going to fire for 8.5 minutes, like it will in the real launch. This is called the green run test, and these are the 8 items that are going to be tested during this whole time at the B2 test stand. This is real. This is happening now. The firing is going to happen probably around Thanksgiving. It hasn't been set. We were ahead of schedule, but the virus we were actually 10 days ahead of schedule when the virus hit in March. So now this thing is probably going to be pushed back to, looks like, probably around November-ish time frame. This is going to be a major hurdle. If this thing works successfully, it will be cleaned up and put on a barge, sent down to Florida, and be prepared to fly about a year later with the Artemis 1 mission. So this is a big first hurdle for Project Artemis. And this is I won't go through all these, but this is schematic of what the Artemis 1 mission is going to do. And once again, there's going to be no astronauts on this one. Artemis 2 will have them. It's just going to fly out there beyond the moon. It's going to test it. The mission is going to last between 26 and 42 days. And that's going to depend on when we launch it. The launch windows for going to the moon, they come up every month versus every 26 months for going to Mars. So it's going to depend on when in that month we launch it and how the spacecraft is doing, if we want to extend it. But it's going to really check everything on here. And if this is successful, this will happen, like I said, like around probably the end of 2021 timeframe. Then we'll get ready for the Artemis 2 mission. We'll fly astronauts on that. They will not land on the moon. They'll fly out and orbit the moon and then come home. And then the next mission will be Artemis 3. And that's when we're going to land on the south pole of the moon. And that's going to have to happen. It's supposed to happen by 2024. Actually, this is an app I have on my cell phone. This was taken a couple of days ago. So it's probably actually right now 1,683 days we have left to land on Tuesday, December 31st, 2024 at the south pole of the moon. So this is something happening, and these big tests are coming. So, and with that, before that, there's another big thing for NASA happening this Wednesday. It's the first commercial crew launch down at the Cape, SpaceX Dragon capsule on the Falcon 9. And 2 astronauts are going to do that test flight this Wednesday. The launch time is 4:34 p.m. Eastern. The weather is only 40% go right now, but weather changes a lot down in Florida. So between now and next Wednesday, it still could be favorable. But anyway, that's something coming up in the immediate horizon. Kind of in the mid-horizon is this right here. Our country is in bad shape because we don't have many young people studying science and engineering, technical fields these days, and especially going in working in the space program. A third of the NASA workforce is ready to retire in 3 to 5 years. And as I just mentioned, we don't have a lot of young people going in these career fields, which is going to really bite us in the future because China is turning out droves of scientists and engineers compared to what we're doing here. And we're going to need this workforce. And we live in a technological world, and it's getting more so every minute. And if you don't have the workforce out there to build, test, and create this technology, you're going to be on the sidelines, and you're going to depend on other people. And I think we learned one thing from this COVID-19, you don't want to be dependent on China for anything because they're worthless. And so I think there's some silver linings going to come out of that, but I think there's a lot of lessons to be learned in the future going forward about getting our supply chain back here in this country. I kind of already hit on this. It's just some more numbers from testimony before Congress about the NASA workforce. Only 4% are under age 30. And to put that in perspective, the average age of the people who did Apollo were 26 years old. Okay, so things have really changed, and we need to get this swinging back the other way, this pendulum. Another thing I always hear about is, heard about it my whole life, is why are we spending all that money in space? We got all these problems down here, and you can pick your favorite problem, and a lot of these problems are serious problems. But if NASA went away tomorrow, those problems would not be solved. They'd still be here. And I'll give you an example of the Great Society that LBJ started in the 1960s with the social programs. Countless hundreds of billions of dollars been dumped in there, trillions by now. And I think it's you could make an argument things really haven't improved that much in any of those areas. A lot of money was spent there. I put this in here because I got this from an astronaut friend. I've updated it over the years with new numbers. The one on here that really gets me is a CC late fee. That's a credit card late fee. Okay, that was what Americans pay a year for basically nothing because you didn't pay your credit card on time. $18 billion. That's almost the NASA budget. Okay. Another thing in here, which is interesting, I think, is Halloween. I got nothing against Halloween. I like Halloween, but I have it in here because Halloween is one day out of a year. And I bet you don't even remember what you did last Halloween. Okay. $9 billion a year on costumes, decorations, candy, and all that. I'm not saying we don't need to have Halloween, but I'm just saying, don't tell me we don't have money to explore space in this country. It should be a priority. And we've got so many benefits out of the space program that I could give you a whole talk for hours on that. But the space program is paid for itself many times over. our quality of life came from going to the moon in the 1960s. The computer, microelectronics boom, all this stuff came from the Apollo program, and countless medical breakthroughs. When you use a GPS or you watch the weather report, I mean, you ever stop to think where that weather report's coming from? A satellite up there, okay? So space program has nothing to be embarrassed about. And people who think it's a waste of money are frankly ill-informed. They just really don't know what they're talking about. They don't know the facts behind it, because numerous studies were done on the Apollo program. For all the money spent to put Americans on the moon between 1969 and 1972, every dollar the United States spent to do that, $14 went back into the U.S. economy. I don't know. That's not a waste of money in my book anywhere. And I dare you to find a government organization that makes a profit like that. So NASA can stand on its own two legs just fine. I think people just aren't aware of what we do with the little amount of money we get. I think that's my last slide. So we'll see if we can do the questions and answers, because I like to always do that. To me, that's one of the fun parts. I remember when I used to go to see talks, you always want to ask questions. Everybody always asks questions. And so that to me is a highlight. I don't want to just be a talking, I don't have a head because you don't see me, but a talking voice. I want to be able to hopefully interact and answer some questions out there. So I think we have time for that now.
Okay, thank you, Dr. Rice. If you want to stop sharing your screen, we can see you. We do have a couple of questions, and while you're doing that, I would say that talking about those stats really brings it home for many of us that are listening this evening.
Yeah, it puts it in perspective, you know.
If you get your camera there. There you go. Okay. We did have a couple of questions. One was, what powers the rover? I didn't see any solar panels. And also with that, the drone, what powers that drone? Is that is it rechargeable? What type of technology? How does that work?
Yeah, good questions. The rover is like Curiosity. It's nuclear powered. And in the back end of that thing, there's a thing called the multi-mission radioisotope thermoelectric generator. That's a nuclear reactor. Okay, it's plutonium-238 or 239 loaded in there, and as it decays, it produces power. So you're right. There's no solar panels on the rover like we had with Spirit and Curiosity. And that's really the way you want to explore Mars, because if a dust storm comes, it doesn't do anything to you. Dust storm killed us with opportunity. Curiosity didn't even blink, because it was nuclear powered, didn't have to worry about the sunlight. So that is the ideal way you want to explore the moon and Mars, especially with astronauts. The helicopter is solar powered and it is rechargeable. There's little solar cells on the rotor blades of that thing, and so that helicopter weighs about 4 pounds, as I mentioned. It's going to be deployed after we're going to land February 18th. It's going to ride along the belly of the rover for several months. Probably, if things, this is the nominal timeline, and things will change once we get on Mars and stuff. But the plan right now is to lower that helicopter sometime in May of 2021. The rover is going to back away probably about 100 or so meters, because you don't want to have that helicopter accidentally crash into the rover. I mean, how stupid would you look? You knocked out your cameras or something. So we're going to lay it on it. We're going to deploy it on the ground. It's going to sit there. The rover is going to back away. It will be taking images of it, and it will do a little flight. In the first flight, it's not going to go very far, and it's not going to, the helicopter's not going to fly very high. It's only going to fly what we think right now is maybe about 5 meters above the surface, and the longest flight back may be 100 meters back and forth. So it's not going to be zipping around everywhere. This is a technology demonstrator, and if it proves successful, I think we'll see more of these type of drones in the future, because it's going to be an amazing thing. It gives you access to, like having a drone. Anybody flies a drone here on Earth, you get a nice perspective of your surroundings and zip in and do things. And it can help plot the course where the rover should go to find something interesting that the rover can't see. So it's going to be a great thing. It's going to be very exciting, I think. And by the way, the helicopter has a name. It's called Ingenuity. It was named by a high school student in Tuscaloosa, Alabama, my hometown. So that's kind of neat. But it's got a name also, and the helicopter I think is going to grab people's attention. But we think it's going to work. It was tested in some simulators at Pasadena, California, at JPL. But I think it's going to work. But we never know because it's never been tried. So the Martian atmosphere is very thin. The atmospheric pressure on Mars is like 10 millibars. The atmospheric pressure on Earth is about 1,000 millibars. So it's a very, very thin atmosphere, almost nothing. So, but that's solar, and it hopes to do.
I have a couple more questions.
Okay.
The turret looks significantly larger than Curiosity's. Is the weight of the turret a significant reliability concern? Are the arms, self-cleaning, lubricating joints considered missions limiting items?
Yeah, you're right. The turret is very different, and is a big device. I don't know the weight of it off the top of my head. I probably should, but I don't. But it's been tested. It's a lot of testing at JPL with the strength of the arm that they can hold it. And you also got to remember when it gets to Mars, it's going to weigh 1/3 its gravity. I mean, 1/3 its weight, because the gravity on Mars is 1/3 here. So it's been tested even on Earth's gravity, and it works okay. In terms of the self-cleaning joints, I don't know. I know that a lot of parts of the arm are sealed, so a lot of dust won't be able to get in there. But there will be places where it has hinges, like an elbow joint and stuff. There's a possibility dust might get in there. But we didn't really have any trouble with our arms on Spirit and Opportunity or Curiosity at this point. We've got them designed pretty well. And we had our arm on Opportunity. It was on Mars 15 years, and it never got stuck with anything. So. And the designs have only improved as we learn by that. So I'm not really too concerned about that. But it's a lot more weight at the end of that arm. You're right. But I don't know the amount of that weight off the top of my head.
Okay. Has autonomous driving safety operation improved compared to Curiosity? Artificial intelligence, self-learning versus hard-coded?
Yeah, because one of the big drawbacks of these rovers is, in football, you don't outkick your coverage. Well, on the Mars rover, you don't outdrive your images, which you can see safely. The record drive for a rover in one day is still held by Opportunity, and that record was 212 meters, okay? And not very much when you think about it. But I think with the artificial intelligence, as you mentioned, capability that upgrades that Perseverance will have, they hope to do 100-meter drives on average, which will be amazing if they can do it. It's going to depend on what the terrain is like when we get down on Mars and Jezero Crater, how many boulders or sand dunes are there. It looks, in some places, it's going to be kind of iffy. You got to be very careful, and you have to slowly prod your way through some of these dune fields. But in other areas, you're probably driving pretty quick. But the thing about driving, you have to be careful. You don't want to drive too fast because you don't want to pass something. Important. And so it's not going to be like the Indianapolis 500 ever like that. Also because there's a big time lag between the command on Earth and the rover receiving it. But yeah, this rover should be more capable and drive autonomously better than any previous rover. And they've got some things they want to shoot for, like standard 100 meters a day, which is that's up there, because I know it doesn't sound like a lot, but compared to our previous rovers, we were doing like maybe 30 to 50 meters a day on a good day. So if they can pull off the 100 as an average, that'd be great. But to me, it's one of these things you got to wait and see when you get there. And you're going to have a science team full of people who want to stop and look around and see what's there. Because, we always have this saying, you don't want to drive by the proverbial dinosaur bone sticking up out of the ground, So you want to make sure you don't bypass any, scientific goodies there.
Okay, we got two more questions and we'll wrap it up with that. Can you explain how the samples will be used to get hard dates that will be used to calibrate the crater density to get an overall surface dating system? And then a last question is, what's the elevation of the landing site?
Okay, I'll take the second one first. I don't know. I saw that, I can't remember right now. If you go to Jezero Crater, it's spelled Jezero, Google that. You can probably get the elevation of it. Yeah, I don't even want to guess right now because I don't know that number. I did when we were doing landing site selection. I did. It's low enough in the atmosphere so the parachutes will work, that's one deal. Is when you land, you have to land at a low enough altitude, so there's enough Martian atmosphere for the parachute to work to slow you down. But so it's safely within those constraints. But the absolute altitude elevation, I don't know. But you can easily find that out. The other one about how do you radiometrically date samples. Well, first of all, you have to have an igneous rock to get an absolute date. If you bring back a sandstone, a sedimentary rock, you're not going to get an accurate date because a sedimentary rock is made of pre-existing pieces of rock that are a lot older by nature. So when we date rocks on the Earth or Moon, these are igneous rocks, usually volcanic rocks like basalt. And Mars, like the Moon, has a lot of basalt. There will be some basalt in the landing site. We don't know how much right now, but that will be one of the things we want to bring back because that's how you're going to get those absolute dates. And what you do is the radioactive half-life. Uranium decays into lead in the half-life, and I don't know the numbers right now, the half-life numbers off the top of my head of uranium. There's also rubidium, strontium half-lives for these billions of years rock samples. But you'll date it just like we do rocks here on Earth. It's a proven technique. It's been done on Earth rocks since we've had the capability, I guess, in the 1940s or 50s. So it's a proven technology, and it's a given that a radioactive half-life of a daughter product of uranium will break down into a percent uranium every 500 million years, or whatever the ratio is, and that's how you work out that. Now, what you do when you get that number for that basalt sample, that will be kind of like your target or your hinge point where all the other dates go from. And if you get that from a lava flow, and then that delta in that lake is on top of the lava flow, well, the delta is younger than the lava flow. So if the lava flow dates at 3.7 billion years old, that delta is younger than 3.7. And we'll have some of that sandstone material and mudstones from the delta. We'll be able to date some of the stuff, but the ages aren't as reliable as igneous rocks for getting those dates. And then once you extrapolate back the age of the lava flow of the rocks in Jezero Crater at, say, 3.7, you look around outside the crater for other areas that look similar, because with spectrometers, we can get mineralogic compositions of the landscape. We can detect other regions where they're basalt versus sandstones or clay minerals. And you can count the craters in Jezero Crater, and you can calibrate that curve because we know that it was 3.7 billion years ago in this example I'm throwing out. So you can start backing it out that way. We did the same thing on the Moon because once the Apollo astronauts got back here, we were able to date the lunar samples. And now we know, like, for instance, Copernicus crater is 108 million years old because we were able to date one of the rays at the Apollo 12 site, and we had samples from there. So you start being able to bootstrap your way around the planet. And ultimately, you're going to want more samples in other regions of the planet to be precise. But it's going to be a game changer compared to what we have now.
Excellent. Somebody, there's one last question, and we'll end on this. It's a pretty straightforward one. What's the life expectancy of the rover? But before you answer that, please let me thank you wholeheartedly from our viewers and our membership. We appreciate you spending time this evening presenting. I think you've made a wonderful case for us all to, we need to get our young people educated and get them to be the next generation that goes to the Moon and to Mars. So with that, I'll leave it to your parting words, and a very large thank you from our organization.
All right, thank you. Actually, I forgot your question.
What's the life expectancy of the,
life expectancy
of the rover?
Well, I think we expect it to last one Mars year, which is 2 Earth years. It's about 687 days or so. But these rovers have lasted longer. Curiosity was the same deal. And it's 8 years later this August, and it's still going strong. So especially when you have a nuclear reactor on there, you're going to probably last over a decade. Of course, something could go wrong at any time. Your mission would end. But I think the track record of what we have, that Perseverance will probably last a good 10 years or maybe 15. I mean, like I said, Curiosity is still going and shows no sign of slowing. So it'll be way beyond its expected lifetime, which was only 2 Earth years. So, if it's going good and strong, it will probably maybe be able to bring some of those samples back to the sample return lander with the Fetch rover working both in tandem. So yeah, so it's a good 2 years at least, and I feel confident it'll go beyond that if we get down safely. And I want to thank y'all for having me back. Like I said, it's almost 5 years ago I did it, and I think the Perseverance rover's name is a good name for, especially y'all folks. Y'all in that corridor up there. It's been pretty tough the last several months, and like I said at the start, I hope things are starting to get a little better for you out here in Arizona. We just opened up a week ago, and still kind of see what's going to happen in the future. But I hope y'all are able to get your life back, and hope this country's be able to get back on its feet real soon. And because we aren't meant to sit around, it's not our nature.
All right. Thank you again. We appreciate you being here. Good night.
Thank you. Bye-bye.